Hi everyone, welcome to Om Learning Lab. In this video, we are going to solve best time to buy and sell stock 2. Now this is the second version of the problem in the series of best time to buy and sell stock. I have added the link in the description for the first version, best time to buy and sell stock 1. For people who haven't checked that out, I would strongly recommend to check that out, get a flavor of that problem and the solution approach, and then come back and watch this solution. Without any further ado, let's get into it. So we are given an integer array prices where prices of I is the price of a given stock on the ith day, pretty much what it was in the first version as well. On each day, we may decide to buy or sell the stock, and we can hold at most one share of the stock at any time. Now, this point is important. What this basically means is that we cannot buy twice. So once we have a buy kind of transaction, we must sell it before we do another buy kind of transaction. That's it. However, you can buy it and then immediately sell it on the same day. So on same day, we can buy and sell. That is allowed. So why this point is important, we will understand as we start digging deeper into the solution. Find and return the maximum profit you can achieve. So we can go through some examples. The first and the third example, I think they are from the first version of the problem itself. The second version is a new one. Anyways, let's take the first example and try to understand what they have done here. So what is the example? 715364. Let's go to the notebook. Okay. So we have 7, 1, 5, 3, 6 and 4. Now if you look at the explanation that they have given for this example, what they have basically done is they are saying that you buy at price of 1, sell at price of 5, then you buy at price of 3 and sell at price of 6. So this gives a profit of 4, this gives a profit of 3, and hence the net profit is 7. Now, the question that immediately comes into mind is, how do we decide where we buy and sell? We cannot have multiple buy. And there is this additional condition that buy and sell on same day is allowed. How do we utilize that? And how do we make this decision? Where to buy, where to sell? And there is no limitation on the number of such transactions, right? If you notice, there is no limitation on how many times you buy or sell. You just can't buy twice. You have to sell before buying again. So how do you do this? How do you go about it? Well, oftentimes it's a good exercise, I would say, to try and visualize these problems. Like if there is profit or loss involved, try to pictorially look at how the problem behaves. So for example, what I mean to say is, if I try to plot this out, let me plot this out, this particular example, and let's see if we can see a pattern over here. So we have zero-based indexing as usual, 0, 1, 2, 3, 4 and 5. Let me just write those here real quick, 3, 4 and 5. And we have our elements from 1 to 7. The values are from 1 to 7. Let me also write those 1, 2, 3, 4, 5, 6 and 7. So at 0th index we have 7. This is the first point. At the first index we have 1. At second index we have 5. At third index we have 3. At fourth index we have 6. And at the fifth index we have 4. Now, do you see a pattern here? So if I try to join these points, I'm getting some kind of a graph here. And if you notice, what has happened basically is, if I just make an observation, as per the example, the purchase has been done here and the sell has been done here. Another purchase has been done at this point. We can call this as a down point. Let's call it D1, down point 1. So here we did the first purchase. This is high point 1. Let's call it H1. Then at down point 2, another purchase was done. And at the second high point, another sell was done. So basically it's like a crest and trough kind of example. These are the troughs, these are the crests. So buy at the trough where the price is as low as possible and sell at a crest where the price is as high as possible. Now, intuitively, this should make sense, right? Because we want to maximize the profit. So any transaction is basically uh, it's sell price minus buy price. Let me correct this. So any transaction, if I look at any transaction that I have, it's basically selling price minus buy price. In order to maximize this quantity, we need to minimize buying price and we need to maximize selling price. So intuitively, it should make sense that if we have a list of prices in an array, buy where the buying price is as less as possible and then sell when it is as high as possible. Now, one question will immediately come to people's mind, which is that it's okay, we buy at D1. D1 is the least value in the given array. So, okay, we buy at D1. Why do we sell at H1? Why shouldn't we hold on and sell at H2? Because H2 is higher than H1. The reason is, see, if I buy at D1 and hold till H1, what is the profit that I am going to get? So it is 1 and H2 is 6, the net profit will be 5. Now, if I sell at H1, there can be two cases. In the first case, either after H1, all the elements were same as H1 or more than H1. For example, hypothetically speaking, let's say at index number 3, there was some another higher point here. Or there was some point which is same as H1 here. So there are three cases possible. Either points after H1 is higher than H1 or same as H1 or lower than H1, which is actually the case in this given example. And those points are before H2, mind you. Now, if the point is above H1, what will happen is first we got the profit of 5 minus 1, which is 4. Now, remember, buying and selling at a same index is allowed. It is here where that point comes into picture. That plays a crucial role. So once I sell at H1, I can again buy at H1 and get this profit, this particular profit. So at index 3, let's say the price was something like 5.5, hypothetically speaking, I can get a 0.5 profit. And then again, after selling at index number 3, I can again buy at index number 3 and sell at index number 4 and get the net profit, right? Whatever profit I would have got if I purchased at index 1 and sold at index 4 directly, I can anyways get through intermediate transactions as well. This is considering a hypothetical scenario. This is not the actual test case which has been given. This is a hypothetical scenario which I am covering here. That let's say after we have a trough, that is the low point and a high point, let's say there is a even higher point after the high point. What happens in between the two high points is either there is another high point, there are multiple high points, in which case there is no issue. We can have intermediate transactions and get the same net profit. Or we have points at the same level, which is basically the same thing. We'll get zero profit, but we can keep buying and selling and eventually we'll get the final profit. And if there is a trough, we will actually get more profit if I sell at H1, because if I sell at H1, I am getting this margin. Then I buy at D2 and sell at H2. I am getting this margin. See, there is overlap. If I purchased at D1 and sold at H1, I would have got this length. Here I am getting this length, and additionally I am getting some more. If I draw at the same level, I am getting this part as extra. So it always makes sense to make transactions at troughs and crests. At low points, you buy, at high points, you sell. That is the whole point that I am trying to make here. Right? So the graphical visualization was to sell across the point that it always makes sense to buy at low points and sell at high points. Because any other case, any other activity that you want to do will always be less optimal, suboptimal than this approach. This is the most optimal approach. Now, one will immediately ask or immediately think that how do we implement this in code? It might get complicated. How do we track low points and high points? Well, as it turns out, we don't have to do that. So first of all, if we see two elements at index number I and I plus 1, I'm talking about two consecutive elements. If I plus 1 is lesser than I, for example, this case, this index number 0 and 1, we will never make a buy and sell transaction, right? Why would you want to take a loss? Now, if I plus 1 is greater than or equal to I, we should always make a transaction. The reason being that why not? Why shouldn't we make a transaction? So let's say this is I plus 1. Let's say some price here, this was the price, and here this is the price. We should always make a transaction because we are getting profit, right? The only argument one can make not to make a transaction is after I plus 1, there is some index, let's say I plus 2, where the price is even higher. But then this multiple buy and sell argument comes into picture, right? You buy here, you sell here, you get this much profit. Then again you buy here after selling and you sell at this point and you get this much profit. So your net profit remains constant. Just a second, my bad. So your net profit will still remain constant. What it would have been if you held on to it, if you didn't sell in the first go, you would still get that as a profit. Hence, whenever you see the solution implementation is quite simple, you iterate through the array. Whenever you see consecutive indices such that I plus 1 is less than I, obviously you will not make a buy and sell transaction. However, if I plus 1 is greater than or equal to I, you buy at I and you sell at I plus 1. Because you can do the same thing again, right? If there is an even higher point. And if there is a, let's say, low point after I plus 1, it's even better because you will get a more margin of profit, which is what is happening in this test case, right? You buy at D1, you sell at H1, and then you go down. So the profit margin, in fact, increases, as I pointed out. This was the point. This was the amount of increase. So all in all, in a nutshell, you buy at low points, you sell at high points. You get the maximum profit. How to implement that? You just iterate over the array, and for two consecutive indices, if the difference between I plus 1 and I is positive, just take that difference. That's it. You don't have to do anything else. It's always optimal to do so. Because in the end, every kind of difference would add up. Let's say it is a continuously increasing sequence, then it will add up. Or let's say there is another trough in between. So if we take consecutive difference, we are actually gaining something, right? We'll gain something. So that's it. That's the explanation for this. And we can quickly implement it in code. Code implementation is very simple. Let's go ahead and implement it. Okay, so I want to take n, which is price.size. Then let's call profit as 0. All I want to do is I just iterate over the entire array, I plus plus. If my prices of I minus prices of I minus 1 is greater than or equal to 0, well then it's always profitable to add this, right? If it is continuously increasing, then profits will be added in chunks. Or if there is a trough after the increase, then we'll get additional profit. So we can just add profit plus is prices of I minus prices of I minus 1. I think that's it. Return profit. This should work. Let's try to run. Okay, let's try to sum it. Okay, accepted. Let's do the same thing in Python real quick. It shouldn't be difficult. N is length of this given list. Then for I in the range, let's take this 1 to n. If prices at I minus prices at I minus 1 is greater than or equal to 0, so let's declare profit here. Profit is 0. Then you can do the exact same thing as we did in C++. Profit plus is prices of I minus prices of I minus 1. And then you return profit. That's it. This should work. Accepted. Let's try to submit. Accept. So that's about the code implementation. Like I said, implementation becomes fairly simple once you understand the key idea for this problem, which is that once you draw a graph, it's very easy to understand that you buy at the trough, the low points, sell at the high points. Because in case the graph is in a zigzag fashion, as given in this example, let's say graph is something like this, you get this much profit and you get this much profit, and this is your overlap. This is the additional profit that you are getting. That if you bought here and you sold here, you would have got only this much. Here you are getting this additional part as the profit. So it always makes sense to buy at low points and high points. And how to implement this? Well, consecutive indices, if the difference is positive, just add it up, because in the end, chunks are going to add up giving the same value. So that's about the implementation, and that's about best time to buy and sell stock version number 2. I'll also make videos on version number 3 and 4, which are slightly difficult to understand and implement than versions number 1 and 2. But we'll do that regardless, because interviewers are going to ask versions number 3 and 4 once you solve the first two versions, and you are expected to solve the first two versions in any coding interview. So I'll make videos for that, but this is all for this video. Thanks for watching.